And we're going to take two. But you already know the answers to all these. Okay. So this is the matrices lesson. We were just talking, and we'll review real quick again, to find where each term is located within a matrix. This is matrix A. You look to the row first, and then you look to the column. So just like if you're coming into a theater and you knew your seat was C4, right? You go in and you look for the row first, and then you look for the column. You look for the column of seats. That's where's your seat? 1, 2, 3, 4. 1, 2, 3, 4. And you'd be right there. It's a dangerous seat, some people say. But you're brave, so you'll sit there. And the same thing applies here. If I'm looking for this term right here, the 3, it's A, second row, first column, A21. It's not A21, it's A, then the row, then the column. Okay. Also, if I look at this matrix, it's always going to be the dimensions. The dimensions are row by column. Okay, so what is the dimension for this matrix right here? What do you say? What are the dimensions for this matrix?
3 by 4.
3 by 4, right? Okay, so those are just the basics. We have to be able to identify and point out things and be talking about the same thing. Okay, so I want you just real quick, I want you to identify what is A12. Go ahead and think about it for a second, and then double check with your neighbor. 5 seconds. And double check with your neighbor. A52. This is matrix A. Remember that the row and then the column goes there. So double check with your neighbor. I don't hear anybody double checking. What do we have? A12. We're looking right here. We're identifying A12.
I thought 5-2.
A12.
Yeah, you said 1, 2 once, but then you said A5 2.
You start from the bottom left or top left?
Start from the top left. Right. So I'm at A12 on both occasions. I didn't change it up. That's what confused you.
So it is negative.
All right. Where's what is the term in A12?
Negative
1. Okay. A24. Think about it for a second. Double check with your neighbor. Another second. A24. Good. All right. What is our A24?
4.
A2, second row, fourth column, 4. Okay. How about A15?
Great question. That's a great question.
So, do we have a value that is in the first row? We have a bunch of values in the first row, but how about the fifth column? 1, 2, 3, 4, 5. There isn't. So it actually does not exist. D and E does not exist. Is a term if it just there's nothing there. There's nothing there. There's nothing in excuse me in that coordinate. This is going to come up again when we start to add and subtract these things. Okay. So add and subtract. Well, basically you've been learning with math so far. You've been learning all the properties of equality, properties of inequality. So associative, distributive, commutative, reflexive, all these properties. Matrices have the same properties as far as addition and subtraction, but when we get to multiplication, there's a couple properties that change. Okay? And that's just something we're going to have to deal with when you get into calculus. That happens again some cases. But when we are doing addition, it is very straightforward how we get our answers with addition. All we look to is we find the term in the first matrix and the corresponding term in the second matrix, and we're just going to add them together. So if I did that, think about that process and how you do that for all 6 terms in each of them. What is the dimension of my new matrix going to be? They're not going to change, right? Okay. So this is going to contrast to tomorrow. When we get to multiplication, it actually gets a little trickier. Okay? With multiplication, there are some different things. The dimensions change, and what you can multiply together is going to have different dimensions. You'll see. You'll see. But today, just start with the easy one here. So go ahead and knock this out. I'm going to go ahead and put my first one, 3 plus 2. And then I'll do the next one for you, 6 plus 1. Go ahead and work all those out. Find your new matrix. All you're doing is adding together the corresponding terms from each matrix. Okay? You can jot it down real quick. You got plenty of room on that paper. Plenty of room. Question, Gene?
I was wondering, well, go. So I was wondering, what happens when they don't have the same dimension?
Here in the future. That's what I'm going to do right here next. And we'll figure it out together, the rule from doing that. So it's a good question. Can I go ahead and change this to 5, please? I'm going to change that to 17. How about the, let's see, we'll call this matrix C. So C13 is what? C13? 14. C21? C22? C23. Okay, pretty easy, right? When we're adding or subtracting, it's very easy. And the application for this isn't just for being able to combine systems of equations. It can also be used just to, add data. If you had a big table of data, you'd be able to add together, similar amounts. It's like very direct. Like if one student's selling t-shirts, another student, all the smalls, you would just add them all together, and you could do that with a matrix. It's just a way to organize a bunch of information at once. So let's look at this one. 1 corresponds to 2. 3 corresponds to -1. What corresponds to 6?
0.
Not 0. It actually, there isn't a 1-3 term here. It does not exist, right? So then my question to you is, when something does not exist, and you add 6 to it, what do you get? 6. Not exactly. Does not exist isn't the same as 0. Does not exist is
6i.
Is saying even the representation of the object doesn't even exist, right? The number 0 represents 0 objects, but it does not exist. It's not the same as 0.
So is I said 6,
Is it what? No. Does not exist is there's no entry to it. There's not even a place to put a value onto it.
So you just don't use that.
Yeah, you can't. There's no term there, and it's actually like the difference between 0 and does not exist is kind of like, that could be someone's, doctorate thesis. It's a philosophical idea, because everything in the universe that we can understand has an object, and then we have a representation, an intellectual representation of the object, right? Those things are never the same, but we are interpreting it and trying to communicate what this thing is. But nothingness is the only, actually this is really far. Nothingness is the only thing where the object and the representation are exactly the same. It is. It's the first step to get into a lot of brain riddles that keep going. So we have to have the same dimensions. That's the thing. When we have addition or subtraction, you have to have the same dimensions, because does not exist plus 6 isn't something we can really compute or even look at this stage with math. But adding, pretty easy, pretty straightforward. Thumbs up for this. Good. Gene, another question?
Yeah, so I was looking at the thing, and so it's A1, A12, A15, and A11, A21, A31,
Yeah.
Why is but
You're looking at the addition or subtraction?
any of them, it doesn't matter. Why is it diagonally?
Oh, I see. Right. continues in the expansion out that way. It's not just expanding down, because I'm not sure. There's a notation, and I think logic notation, that describes what that diagonal is. But you guys get the gist of what that's saying. It's just saying an ever-expanding matrix is going to always is going to respond this way. All right, addition out of the way. Subtraction is very, very similar. You're looking at a 2 by 3 and a 2 by 3 matrices. Our ending difference of the matrices are going to be in the form of a 2, 3. So go ahead and do it. We can do this one together, the first couple. 3 and 2. Subtract and get 1. 16 and 1. 15. Keep on going. Make sure that you are paying attention to the signs. -6 minus a -8 changes the signs around. Double check. So you're just subtracting the corresponding terms. It's just one question at a time, but the questions are never harder than, hey, what's 3 minus 2? What's 16 minus 1? It's not any trickier than that. Tomorrow gets a little tricky. Today, not as bad. Okay, what goes here? -2? 7? 27. Done. What's the crux of this? What's the hardest part? Anybody point out the hardest part of this? Waiting for it?
Dumb out, like
Overlooking.
Writing all of it.
Writing all of it. The hardest part with matrices is it takes a lot of writing. Okay.
This is like when you teach how to
What? Tell us all. What?
I was going to tell Alan.
Okay, Alan. You have to tell us. All right. The last bit for the basics of matrices is scalar. Scalars, you could think of it as your entire matrix is getting scaled up. Okay. So if these were T-shirt sizes, small, medium, large for boys' size, small, medium, large for girls' size. If you're just scaling, a scalar basically scales everything up. And you can think about it the same way from vectors. It increases the magnitude. A scalar increases the magnitude. So that is one way it's related. But if I'm doing 3A, I want to figure out what my 3A matrix is when A is this 2 by 3. We're going to end up with the same number of terms. All you have to do is take 3 and multiply it by 5. Take 3 and multiply it by 2, and so on. You're just basically scaling up the entire matrix to get a new one that is 3 times larger. It's easy. So 3 times 1 is 3. Down here, 3 times -2, -6. 3 times 4, 12. 3 times 10, 30. Just put 6. Okay. Scalars are just applied that way. You have to know this intro day, and when we get to tomorrow, you'll see tomorrow is really the big step. This is just intro, just so you know how these things function. Add and subtract and scalars are pretty straightforward. Okay. What else do I want to hit with this? Thumbs up, sideways, down for this. That's good, right? 2 thumbs down, Gene. Oh, really? I reject. That does not exist.
2 negatives make positive.
That's right. When multiplied.
He's just pointing out how the difficulty level of today is scaled down from what we're going to deal with tomorrow.
This is true. Okay. Thank you for interpreting that. All right. I'm going to come up with a new, what's it called, where I give someone candy for being my 200th subscriber. What do you call that again? Just a giveaway? There's nothing clever about this.
I think your rewards should scale.
So what's the 200? What should the 200 be?
Get their name on the board.
Forever. In permanent ink. Yeah.
How much do we have to buy each win?
No, I don't take bribes.
Have so
What should the giveaway be?
A gift card.
A gift card?
Free coffee.
Free coffee.
You bring them Starbucks.
Don't have to do about money.
What if they don't live here?
Well, like you go give it. Like you call them to your coffee.
What?
Yeah, it's like well.
Didn't he pass away? Oh, so they die? It's weird. It's a weird giveaway.
You have to spend 5 hours in the drawing stands and waiting.
All right, I'm gonna pause. All right, apparently, if you're the 200 subscriber, you get either coffee, some kind of coffee from Starbucks, or some type of candy item to be determined. If you don't drink coffee.
You don't drink coffee.
Okay. All right. How about subscribe on 3? 1, 2, 3.
Subscribe.
Please do. Get your candy or coffee.